Right, continuing in chapter 2, section 7, we're going to find the inverse of a function, which means we're going to switch and solve. So this is our 4-step process in finding the inverse of a function. So in examples A and B, we're given 2 equations and we want to find the inverse function. Sometimes we call it g of x. Sometimes we use the notation f inverse of x. Right, the first thing we're going to do is we're going to replace the function notation f of x with y in the equation. So in example A, our objective is to find the inverse of the function. And the process we go through is we change f of x to y. And step 2 says we want to interchange the x and y, switch the places, because that's what inverses are, switching x and y. So where y is, we'll replace it with x, and wherever we see x, we'll replace it with y. So if there's multiple y's, we change them to x, and if there's multiple x's, we change them to y. Step 3, solve for the y. So now for this new y we have right here, we want to solve this equation. So let's isolate y. So first step is to subtract 7 from both sides. Taking this column format and putting it in a row format, we have this. And to finish solving for y, we want to do the inverse operation and divide by 2. So we want to stack the whole fraction, one big fraction bar, divide by 2. Now I'm going to trade sides. I'm going to put y on the left of the equal sign, and I'll put x minus 7 over 2 on the right-hand side. Step 4, write the inverse in function notation as f inverse of x. So that just means take this new y and replace this new y with f inverse of x. So if someone sees this last line right here, they'll know that starting with f of x, that this is the inverse equation for f of x. And depending upon how MyMathLab wants your answer, I wanted to show you a couple different ways that you could write this answer right here that MyMathLab might be wanting. So I'm going to keep the inverse notation. Okay, something we can do right here is we can actually separate x minus 7 and put each of those terms over 2. I can't just put one term, I can't just put x over 2 and not the 7, so I have to put the 2 underneath all the terms of the numerator. So had there been 3 terms up here, remember terms are what you add or subtract, then I'd have to take all 3 terms and give them a new denominator, its own fraction of 2. So another way to write that would be x over 2 minus 7 over 2. Yet another way is looking at this first term now in this new expression. I know there's an understood 1 here, so 1 times x. Another way you might see this written is 1/2 pulled out in front of the x. Just make sure the x doesn't fall down in the denominator with 2. It's either out to the side like this or a little bit raised. So all 3 of these answers are correct, just not sure which one MyMathLab might want. And hopefully it's just this one right here and you don't have to like change it to a different form. Okay, so for example B, again, we want to find the inverse equation for this function. So we replace f of x with y. Then we step 2, switch all x's and y's. Then we kind of step back and look at this equation and go, okay, I have to isolate y cubed and then take the cube root. So let me first add the 1. And lining this up in a row format. All right, let's divide out the 4. Let's isolate y cubed, so let's divide out the 4 using the inverse operation of division. The 4's will divide out. Now I have y cubed. I'm going to actually put y cubed on the left-hand side of the equation. I'm going to just switch sides and put this fraction on the right-hand side. I'm going to come up here. All right, to get y by itself, I need to bring in the cube root. So the cube root of y cubed, that's the inverse operation. And then over here with this fraction, okay, typically we put the whole fraction underneath the cube root. The cube root undoes the cube power. So the cube root, third power, Now I'm going to take out y, but remember we do not need absolute value because this is an odd root and it's only going to have one solution. And there's nothing more you can do over here other than just rewrite it. Okay, and just make sure that this whole fraction looks like it fits underneath a big old radical right here. Okay, and the last step is to write an inverse function notation. Right now it's not revealing to us that this y is an inverse function, but it would be revealing to us that it's a function if we use this f inverse notation. And I would say that that's probably the way it's going to be accepted here, unless you want to separate this fraction like we did in the first example right here, but just make sure that you keep everything underneath the radical if you do separate and put x over 4 and 1 over 4. All right, we're actually not going to do example C. C is pretty involved, and I know that that's not going to be something that you're going to be assessed on and tested on, not on any of my exams or on the final exam. So that one's pretty complicated. So we're going to do two other problems that are similar to ones that you'll see on homework and then also tests and final exams. All right, so I'm going to call C down here a new problem. Let's say that we have the function, the rational function, f of x equals 7 divided by 3x minus 5. And we want to find that inverse function. So f of x becomes y, and this x down here gets switched to y. Okay, notice that we never did have a fraction up here, so how do I handle, oh, how about if I switch, oh, pardon me, I did two things too fast. Oh, I'm so sorry. So let me just go ahead and say this was y, and I'll change it to x here. Yeah. All right, so how do we get rid of this fraction right here? Well, one thing we can do is we can take this x and make it a fraction. And then mathematically, we can cross multiply. So what we're going to do is we're going to multiply this x into this entire denominator here. So I'm going to say x times, and we should put parentheses 3y minus 5. And then that's equal to the cross multiplication here of 7. So I just multiplied x times this quantity. That means parentheses, and then that set that equal to the other cross multiplication of 7. Now what we need to do is we need to distribute the x inside this parentheses. So x times 3y would be 3xy, and then x times minus 5 is minus 5x, and that's still equal to 7. All right, so again, we switched the x and y, we cross multiplied because of the fractional situation here, we distributed. Now we need to get y by itself. So to get y by itself, first of all, let's add 5x to the other side of the equation. These will cancel. I've got 3xy equals, and I'll just line this up in a row, 5x plus 7. All right, and we're actually not even going to do example D, and we won't need this graph right here. So I'm actually going to kind of come down below here. Okay, so now I want to solve for this y right here, so I'm going to divide both sides of this equation by 3x. Since everything's being multiplied, I can do the inverse operation of division. So let's divide by 3x here and divide by 3x here. So this 3x divides out, and I've got y equals 5x plus 7 over 3x. To show somebody that we found the inverse function, we would replace y with the inverse notation. And that would probably be a good answer. Like the first couple of examples though, or at least the first one, okay, another way to write this is we could separate, we could take this whole, this is one group down here, this is called a monomial. So what we could do is we could take the 5x and put it over 3x, and then we have a plus sign here, plus we could take the 7 and put it over 3x. And then if we wanted to, we could look inside this fraction right here and say, well, these x's can now divide out. So I would have 5/3 here plus 7 over 3x. Likely this is going to be the accepted answer right here, but do know mathematically that we could separate here, break this apart, putting both the terms of 5x and 7 over 3x, and then seeing once we do that, that we could, within this fraction, simplify it further. All right, let's do one more of the same. So I'll call this D, and I'll put D right over here. I might encourage you to stop the video, see if you guys can find this inverse function here using this as a model over here, because it has the same process. F of x becomes y. Now we'll switch the x and y. Okay. What did we do here? Well, we put x over 1 and we cross multiplied. So x multiplied into 5y minus 1. Make sure and put parentheses around 5y minus 1 because you've got to distribute that x to both these terms. You have to multiply x into both those terms. And this is the correct presentation that suggests that work. This multiplication is 2. If we look back over here, we distributed the x inside, so we'll get 5xy minus x equals 2. And we want to solve for the new y, so let's add an x to both sides. And then to isolate y, since everything's being multiplied, I can divide by 5x on both sides of the equation. And again, like we did over here, you could put x over 5x and 2 over 5x, and then you could simplify the x over 5x if you wanted to. But I'm pretty sure that this is going to be the accepted way. They're both right. It's just a different presentation. That's all. So what we just did was we found the inverse given an equation. We found the inverse function given an equation by following these set of steps right here.